For years, the story in AI has been pretty simple. Bigger is better, right? We've seen these massive language models with hundreds of billions, even trillions of parameters. But what if that's not the whole story? What if the real key to smarter AI isn't about more brute force, but about a much, much better blueprint? Well, a brand new paper just introduced a tiny model that seriously challenges everything we thought we knew about how AI reasons.
So, to really get why this tiny model is such a big deal, we first have to understand a pretty surprising weakness that's been hiding inside even our most powerful AIs. It's a kind of provocative question, isn't it? I mean, we see these AIs writing poetry, translating languages almost perfectly, but then you ask them to solve a really complex, multi-step logic puzzle, and they just hit a wall. The paper we're looking at points out that the core architecture of these giants is, and I love this word, paradoxically shallow. Basically, they process tons of information in a super wide way, but not a very deep one. And that really limits them when they have to do something that requires a long chain of logical thought.
And this is where you see this really interesting split. Large language models, LLMs, they're fantastic at things that rely on pattern recognition. Recombining stuff they've seen in their training data. But they completely stumble when a task requires a deep, step-by-step chain of logic. We're talking about things like solving a seriously hard Sudoku puzzle or figuring out the best path through a complex maze.
The researchers here are pretty blunt about it. They're talking about that popular trick called chain of thought, where you prompt an AI to think step by step. But they just call it a crutch. And why? Well, because it's super fragile. If the AI makes one little mistake early in the chain, the whole thing just falls apart. It's forcing the AI to reason on the surface, using language, instead of using a deeper, more powerful way to compute.
Okay, so if the current way of building AI is fundamentally flawed, where do we even look for a better design? Turns out the answer was kind of right in front of us. Well, inside of us this whole time.
That's right, the human brain. It doesn't need trillions of parameters to reason its way through complex problems. It pulls off these incredible chains of thought so efficiently, not by thinking out loud in words, but by computing in this deep, abstract, internal space of ideas. So the researchers decided to use this amazing biological computer as their blueprint.
They basically boiled it down to three key principles from neuroscience. First up, hierarchical processing. Your brain has different parts for big picture strategy and for the nitty-gritty details. Second, temporal separation. It uses different speeds, just like that famous thinking, fast and slow idea. And finally, recurrent connectivity. It has these feedback loops that let it constantly check its work and refine ideas over time.
So, inspired by these incredible principles from the brain, the researchers went and designed a totally new kind of AI architecture.
They call it the Hierarchical Reasoning Model, or HRM for short. And instead of one single shallow processor like we see in LLMs, this thing is a system that's built from the ground up to reason in layers, just like the brain does.
And the way it works is actually super intuitive. Think of it like a company, right? The HRM has a high-level planner, that's the CEO, thinking slowly, setting the big picture strategy. The planner then gives a task to the worker module, that's like the engineer, who works incredibly fast to crunch the numbers and execute the details. Once the worker's done, it reports back, the planner checks the progress, and then sets the next high-level goal. This whole cycle allows for really deep, structured thinking.
And get this. This is the part that's just wild. This entire brain-inspired model has only 27 million parameters. No, that is not a typo. It is a tiny, tiny fraction of the size of the major LLMs. We're talking about a real David versus Goliath situation here. Okay, so it's a clever design, it's tiny, but does it actually work? The researchers decided to put it to the ultimate test. They pitted their little model against the giants on challenges that were specifically designed to make other AIs fail. The stage was set. I mean, could this new architecture, this tiny model, really outperform models thousands of times its size, especially on the very tasks they're known to be terrible at?
And the results? They are just stunning. On a set of extremely difficult Sudoku puzzles, the big, leading LLMs, even with that think step-by-step prompt, they scored a flat 0. They couldn't solve a single one. And the tiny HRM, it solved over half of them. Just incredible.
And it wasn't a fluke.
It was the same story for another classic reasoning problem, finding the best path in a really hard 30 by 30 maze. Again, the big models, 0%. Total failure. The HRM? It cruises in with almost 75% accuracy.
And if you're not already blown away, this might be the craziest part of all. The HRM did all of this after being trained on just 1,000 examples for each task. It wasn't pre-trained on the entire internet. This kind of data efficiency is just unheard of, and it suggests its architecture is just fundamentally better at learning how to reason.
But here's where the story gets even more profound. It wasn't just that the HRM succeeded, but how it did it. What was actually going on inside this little model as it was learned?
When the researchers actually looked inside the trained HRM, they found something truly remarkable. The model had, completely on its own, learned to organize itself in a way that looks shockingly similar to the structure of a biological brain.
Okay, so on the left, you're looking at a map of something called the dimensionality hierarchy in a real mouse cortex. Just think of it as an organizational chart for reasoning, where high-level thinking is more complex and flexible, what we call higher dimensional. Now look at the image on the right. That's the HRM. And what's just incredible is that through training, it spontaneously developed the same pattern. Its high-level planner became complex and high-dimensional, while its low-level worker stayed simple and low-dimensional.
And this isn't just a hey, that kind of looks similar thing. The numbers back it up. The ratio of dimensionality between the high and low-level parts in the HRM ended up being unbelievably close to the ratio they measure in an actual mouse brain. I mean, nobody programmed this in. It was an emergent property. Something the model figured out on its own was the best way to learn to reason.
Which brings us to what the authors themselves said, that the model autonomously discovers a principle that scientists think is fundamental for reasoning in biology. It didn't just learn what to do to solve the puzzle. It learned how to organize its own internal mind to do it in the most efficient way.
So all of this, it really makes you stop and ask a critical question. This tiny little model suggests that for years, we might have been obsessed with brute force, just scaling up models bigger and bigger, when the real secret was a better blueprint all along. Maybe the path to truly intelligent systems isn't about building a bigger engine, after all, but about finally understanding the architecture of intelligence itself.